Today a few people not joining the session, but still will continue. We'll do share the video. So guys, in last session we done this tab mode. So anyone have any doubt regarding this tab mode? So today we'll have to discuss about the NATing. So one part of NATing today we'll do complete, and again we are going to use the physical setup. So we have a very similar kind of topology, the last which I've shown you. So again, this is my LAN infrastructure, and this is my WAN. And in between, I'm using Palo Alto PA500. All right. So in between, we are using this PA500, and the LAN traffic which goes to internet will go through with this LAN and WAN. So today we have to perform the NATing part. So let me just try to explain about NATing. So do you guys have an idea about NATing? What exactly the NATing?
The NATing is wherein we convert private to public IP addresses. For example, static NAT.
Okay, all right. So guys, NATing is all about translation. If I'm talking about this NATing, so it's all about translation. Translation of what? Translation of IP addresses. Translation of IP addresses we call NATing or network address translation. So guys, basically we have, you all know about the public and private addresses. We have two kind of addresses. First is private and next is public. So it's based on requirement. We can do use public and private addresses. Basically in LAN infrastructure, we do use private addresses. For public internet routing, we do use public range of IP addresses. So there is a certain range which we do use for this private translation. So in IPv4, there is basically three usable classes, and accordingly we have private ranges. A for class B, private ranges /star, and for class B, 192.168.0.0/16. This is the private range of class C. So except these three ranges, all addresses belongs to public. All right, all addresses belongs to public, either it's A, B or C. Except means if you are using 11, 12, so all IP addresses belongs to public. So if I'm saying translation, so guys, there might be possibility of translation, like we can do start translation from private to public, and it also be possible we can translate public to private, and it is also possible we can do translate addresses from private to private. So if I'm talking about NATing, so it doesn't means we do translate public to private or private to private. Normally people do think that if we are talking about this translation or NATing, so it means private to public translation. So it is not like that. It can be private to private, it can be public to public, and vice versa. So see guys, public, private to public, public to private to private, these translation can be possible. These kind of translation we can do perform. As well, public to public translation can also be performed. Means there is possibility. If you are not using, that doesn't matter, but you can do translate. Means devices doesn't understand public private. It just do only understand translation. If you do want to translate a public IP 1.1.1.1 into 2.2.2, so it do translate. It do not check whether you are trying to perform public to public, private to public, or private to private. For device perspective, it is only just translation. So there can be all possibility. When you do go internet, so you do perform public to private translation. All right, when someone try to come from outside, so it come on public IP and public IP get translated into private. In case of static net, basically when we do try to access any web server which is in data center or DMZ, so when we do request for access, so basically what we'll do translate public to private and private to private. Private to private translation will always be in LAN, like we do use for lab purpose, we do use a translation which is private to private. It also be possible at some ISP, and you do see like people do translate private public to public addresses also. So it is all design perspective, but you just have to forget that we can only do translate private to public or something like that. So the general meaning, or in general, we can say translation is all about IP translation is all about your NATing. If I'm saying NATing, so NATing means simply we are trying to perform a kind of translation. What kind of translation? IP address translation. If I'm saying IP address translation, it means we are talking about the layer 3 header part, because IP will do work at layer 3. So if I'm saying about netting translation, so either we can do perform source portion of the address or destination, or it might be possible in some scenarios we required source translation as well destination both. All right. It is not like it only we do perform translation for source address and destination address at a time, but it is also possible like we can do translate both portion at same time. So if I'm saying natting, so natting means it's about layer 3. So either we do translate source portion or destination, or it is also possible we can do translate both. Apart from this, if we do talk about natting, so we can do perform source port translation as well destination port. Source port basically random, destination port you all know about, well known. So if I'm saying about translation, so translation can include your IP and port translation. We can do either translate source port, destination port. We can do translate source IP, destination IP. So in very simple language, we can say if I'm talking about this NAT translation or NATing, so it is always about your IP translation or port translation. So guys, if See, if I'm saying about source, if I'm translating source portion of the IP, so we called it source NAT. If I'm translating source IP address of the source portion or source address of the IP header, so we called it source NAT. If we translate destination portion of the address, so we called it destination NAT. All right. If I'm saying I'm trying to perform translation of destination portion, so it is basically your destination NAT. So first we'll have to understand source NAT. Okay. All good till. So see, if I'm saying source NAT translation, so source NAT translation can be like this. Source NAT means source portion of the IP header, and source NAT also known as hide NAT, or we can say PAT, port address translation, and source NAT. In source NAT we also do perform dynamic NAT. So these are the categories basically we do perform. So if I'm saying hide NAT, so it means we are trying to perform source portion. If I'm saying PAT, port address translation, so still I'm trying to say source NAT. If I'm saying dynamic NAT, so still I'm trying to say this source NAT. Is it clear to everyone?
Yeah, it's clear. Thank you.
All right. So see, guys, basically, if we do talk about source net, so how exactly source net work? That we also have to understand. So see, let's say this is my Palo Alto. Source net is basically, if I'm saying source net, hide net, so it is basically PAT. We are trying to perform port address translation, nothing else. So this is my internet, let's say. And here we have one web server of Facebook, and I'm trying to access this Facebook. So how this basically work, facebook.com. So it is my server. So see, these are my user machines in my LAN, which is trying to access public sites. So how exactly it do work? That we have to understand. So let's say this is my WAN port, and this is my LAN port. In LAN, let's say IP address which I'm using 10.1.2, and the WAN IP address which I'm using on interface 1.1.1, and here gateway address is 1.1.1. So in order to access this web server, which is let's say having IP address 3.3.3.3, how your NAT will work. So you all have to remember this process, how exactly it do work. So in order to access this web server, how exactly it works, that we have to understand. So this is my management port. So when you do try to send traffic, when you do try to send first packet to this web server, so before this you have to resolve the DNS address. You have to be know the address of this Facebook. Once you got the address of Facebook, you can do access the Facebook. In source 10.1.1.2, in destination 3.3.3.3, and in source, so of course you do use source port. So let's say source port is 49,522 and destination port is 80. So this is your packet which comes at firewall, and we called it before NAT or pre-NAT. Pre-NAT packet, we haven't performed any kind of translation. So when it comes here at firewall, so firewall check the rules. What rules required in order to go LAN to WAN? We required access rule, means allow rule. As well, along with this access rule, we required one NAT policy. NAT policy, in order to access internet, in order to go outside, because if you are using private address, so you cannot go to internet. So in order to access internet, you should have to use public IP. But for thousands of users, let's say if in my organization I have thousands of users, we cannot do provide public IP to each another user. So we can do translate this whole IP range into this WAN IP. So what IP range I'm using here? So see, IP range which I'm using in LAN, which is 10.1.0/24. So whatever the traffic which comes from this subnet, we do translate into the WAN IP address which is configured on my interface. So that's we call what? PAT or source translation. So after NAT, how your packet look like? So see, after NAT, your source IP get changed. Now the source portion of the address get changed from 10.1.1.2 to 1.1.1.1. And guys, destination portion remain same, 3.3.3.3. And the very important thing, port number also got changed. So it uses a random port number any other for NAT table. In case of Cisco router, it remains the same port number which basically tried by user, the same port number you do check. But in case of this Palo Alto or checkpoint, you do check NAT port address also get changed. So let's say it added new port number which is 34,001 and destination portion remains same. So if I'm saying guys source translation, or if I'm saying hide NAT, if I'm saying this patch, so everything basically doing only one process, which is like they are doing to translate source portion of the address. As well, it also do one more thing, it do perform translation of ports. Am I correct or not? See this whole diagram and try to analysis, try to check which portion of the address we are trying to translate. Source portion. So see, source portion is this. So if packet is not translated, so we call pre. After translation, so yeah, this is we call translated packet. So which portion of the address we change? Source portion, source IP and port number. Destination portion remains same. So that's why we called it source NAT. All right, every request will look like this only. When it traverses through the firewall, the source IP and port number get changed. Is it clear to everyone what I'm trying to explain? So when it goes to server, so how server will receive? Server will receive a packet from 10.1.1.1 and port number would be 001, and destination portion remains same. So what destination IP is there? 3.3.3.3, and port number is 80. Source, destination. So when it replies, so reply packet comes. How reply packet comes? See, reply packet look like this. When this server replies, so in source, it just added what? 3.3.3.3, and port number also get changed. Destination portion look like this. It added 1.1.1.1. And one more thing, the port number also look like this, 24001. Is it clear to everyone? When it comes here, so because we have a NAT translation table, so from which portion of the address it matches with this. So firewall will check, oh, this is the entry which is in my NAT table. It check, oh, which user will request it. So it got the LAN entry pre-NAT table. So it checks and it just send it back to. On the basis of this this part, it do recognize which LAN user generated the query. So it send it back to user, and user can get access or open the website in this manner. This is clear to everyone what I'm trying to explain? Guys, come on, answer me.
Yeah, man, it's clear.
All right. Everyone does understand this all right. So we'll do perform this. So see, a very similar kind of setup we have. We have Palo Alto physical and we have users. We have WAN link. So we are going to translate and we'll do have to analysis the log of this translation. So first we'll do perform the patch. So in order to access, we'll have to check my device IP, which is 5. So this is my physical firewall, see guys. So the very similar kind of topology which is already we checked in last session. So this is my LAN, this is my WAN. So I'm going to do again verify LAN and WAN. So see, this is my LAN and this is my WAN. Which IP address I'm using on WAN interface 101.254, which is acting as a WAN, and which IP address I'm using on LAN 10.3.3.1. In order to check, we'll have to go on the LAN devices. So these are my LAN devices. These are my LAN users. So we'll have to verify end-to-end connectivity, very similar to yesterday. So this is my Windows user, which is behind LAN. So in order to test it, in order to check it, what I can do, I can show you the IP config. So you just do use the command IP config, and now just do ping. See, LAN connectivity looks good. And in order to verify next hop ISP address, we'll have to ping from Palo Alto 500. So we'll have to just access it with the help of SSH. So see, you got the access of Palo Alto. So I'm going to show you the routing table, how routing table is looking. So show space route, show space routing space route. So see, we have interface and pointing one default route. And now we'll have to check next hop. Ping source 192.168.101.254. In source, we have added the interface IP, and next portion which we have to mention here, or next IP address, which is your next hop IP. So it's look good, and there should be internet access before we do perform netting. So see, there's internet access. We are getting internet access on here on firewall. Till anyone have any doubt? So guys, before trying to, let's say if you do perform the source net, so before trying to perform source net, what all the things you have to check on firewall routing perspective? Firewall perspective, you have to check these three things at firewall. First, routing. In routing, there must be one static default route. Which route? Static default route, pointing toward next hop. ISP. After doing this, you got internet access on your device. It can be a router, firewall, any device. All right. For further, for name resolution, you can also do set your DNS address on firewall. Once you do configure these things, you have to check your LAN configuration, LAN interface configuration. Accordingly, it should be pingable. And the next thing, you should have to check your WAN interface connectivity from next hop. After doing all this, you are very comfortable, you are okay with this. Now last two things which required in order to successfully provide internet at user end, the next thing which required, which is your NAT policy. NAT policy for LAN users, as well allow rule. So in order to perform this source netting, you always have to just remember three things. First is about your routing table construction. Routing table must be configured with up interfaces as well. It must has one static default route pointing towards next hop, which is acting as an ISP in your case. And last thing, we have to configure NAT policy and allow rules in order to allow internet to our users, which is sitting in LAN. All right, guys, anyone have any doubt, any question, you can ask me. The same kind of setup you can do configure at your lab, and you can do WAN link, Palo Alto, LAN users management DMZ, and you can do perform this. So see, in order to access internet, what we can do perform NATing, and the static route will have to also verify with CLI. So in order to verify, we can check. See, there is a static route pointing towards 101.1, which is my default gateway. All right. So interfaces looks good. There is one static default route, and last two things we have to configure, which is about policy and NAT. So first I'll do allow traffic from LAN to WAN. is I think already rule. Allow internet from LAN. So this is the policy which I'm doing. I'm going to do create. So in source, who is coming? LAN trust. In destination, it always be WAN and trust. And applications, whatever the application you want to allow, that you can mention here. But as of now, let's say I'm saying anything which you want to access from inside to outside, it just allowed. And here also you say any. And now log, you need log at the session of starting as well ending, and action should be allowed. So now you have to say okay. Once you do configure this policy, you have to come at NAT portion. So I'm just using this rule at very top at first, and now we'll have to check the NAT portion. So see guys, NAT rule I'm going to do create. So I'm just going to do add rule. Source NAT or PAT. So how traffic comes? It comes from LAN trust. Where it goes? Guys, what would be the destination zone? Can anyone tell me? Come on. So I can understand you have concentration, you all are hearing. What would be destination zone in NAT policy? Ravinder,
The one.
Van. That is van.
WAN destination, yes. So WAN on trust, to whom you want to translate. If you do select any, so anyone which is part of this LAN source, when it comes at firewall, so it just get translated. As well, now you have to come. This is we are telling about original packet. So anyone can come from source, which is LAN, and it can go anywhere on destination. It is optional. We can do define the WAN interface. If you do not define, so it's okay. It is understood. If you do define here interface, so it is okay. Otherwise, you can left it blank. If you do define here interface, so it must be correct. So in destination zone, destination interface must be WAN or whatever the interface you are trying to use. So see, here we have two portions. First is about source, next is about destination address translation. So first we'll have to complete all types of source netting, then we'll have to move on destination portion. So guys, we'll have to use the source net. When you do select this, so here we have dynamic IP endpoints, and it is asking about interface translation or translated address. So select interface translation or interface address. Now select interface one by one and see it automatically pick your configured IP address which is on interface. So dynamic IP that we also called in Palo Alto DIP, dynamic IP endpoint, and we are trying to perform interface netting. So destination portion, we don't have to perform anything in the destination. So never touch this portion when you do try to perform source net. All right. So anyone who's come from LAN get translated into this 101.254. Now you have to say okay. And I'm going to do use at the top this rule also, source net or PAT. Now in order to perform all this, in order to make it check, we'll have to commit it. Once you do commit it, it just reflect. So see guys, it's look good. Once we do complete this translation part, we can do further check it. See, it take little bit time in order to commit. So we'll have to wait because we are doing on physical box.
Okay, sir. Yeah, when you created that policy, so when you set the any, when it comes from the LAN,
Yes,
right?
means any address.
Any. For example, any user can use that. When it comes from outside to inside network, at that time you set any from source. That means the user
From
can access.
outside network, I haven't said anything. See what direction I'm using. You'll
Yeah,
have
yeah.
to check
Please
it.
just show that policy.
See, I've
So
just created a policy from LAN. When
LAN,
people come
right?
from LAN, it
Yeah,
can be
yeah.
any address.
Okay.
When they try to go to access any website, Facebook, Yahoo, I cannot do defined destination.
Okay.
So when people come from LAN and trying to go to outside
Mm-hmm.
untrust, they should get translated. Which portion of that does get translated? Source portion.
Source and distance.
See the theoretical part which I've explained. So we actually performing a very similar thing. Source portion we are translating, and port number also get translated. That's why we called it DIP
Mm-hmm.
or dynamic NAT, dynamic IP port. And in allow rule also, if you do check, allow internet LAN. So there is only LAN trust too, WAN untrust. So people can go outside, but cannot come from outside. But reply traffic will come on the basis of state table.
Okay. Yeah, yeah, yeah. Thank you.
Anyone have any concern regarding this? So see which portion we are translating. Outbound traffic we are translating actually, which is going from LAN to WAN. So see we done it. It's 99%. So it is almost done. So we can check it. It it just show you the commit after some while. So just come on here and trying to ping. So in order to check your configuration, you have to be very sure about the correct, you have to be very correct about your gateway MAC address. It should be LAN interface. So 10.3.3.1 I'm using. And what about DNS? See the DNS address. There must be a valid DNS. So I'm using 10.c4.2.2. So I'm just showing you IP configuration first. So you can use DNS server, valid DNS server 8.8.8.8, 4.2.2, IP is 3.3.3, gateway is 10.3.3.1. And now guys, we can do generate traffic. Further, you can do disable this interface and you can do enable once. Now you do ping anything. You do try to ping www.yahoo.com. So see, it is pinging. It is translated by firewall. And if we do browse anything, so it also go outside. So what kind of translation, what kind of browsing we can do? Perform anything. We can do use Facebook. Okay, so there is some decryption which is going on. So let me just disable this decryption policy. Later I'll do tell you that what is this decryption. So till it is committing here, I can show you the log. So I'm just trying to ping on which IP. See, I've just pinged for Yahoo, so I can show you the log. 106.10.250.10. That's I'm continuously pinging. So in order to verify the log, we'll have to come here at firewall. So firewall will give you the log. See the latest log. See, I think this is the most latest 10.3.3. Some web browsing traffic and some ping traffic which I have sent. See 106. So you do click on here. Now you can verify. So guys, you do perform session ID. So session ID is 635. Action is allow. How we allow this traffic from policy, what application I was doing, what application I was using inside ping. Rule, which rule we are using? Allow internet. Is it correct or not? See, and now come here at source and destination portion. See, the source is 10.3.3.3 and destination is this 106.10 dot. This is pre-NAT packet. Source is this, destination is this. Because it is ICMP port packet, so port translation is not be there, and Singapore IP, which I'm trying to use, but IP address get translated from source 10.3.3.3 to the WAN IP or NAT IP, which I've used, which is actually interface IP, and destination portion remains same. Is it clear to everyone what I'm trying to explain? See, there's few more traffic for port number 80 that you can do understand. So when anyone come from the source and trying to go to outside WAN IP, see WAN IP is this, on which country it is trying to connect? Germany. And source portion of the address get translated into WAN IP. We are trying to use PAT, so IP will be remain same, one IP which we are using. And the very important thing, if you do check, port number also get translated. I was trying to send a packet with source port 49,000 229, but when it comes here at firewall, so firewall will added some random port number which is 32,745, and see destination portion, does it changes? No, destination portion will be same. So that's I was explaining. Anyone have any doubt, any concern, you can ask me. Anyone have any concern?
Not me. It's clear for me. Thank you.
All right. What about other guys? So see, just I'm trying to browse now some web page because my policy get applied. So you can do access easily your Facebook, YouTube, anything at your LAN machine. So these are the tasks which you have to perform in organization also. So see, now user can do browse Facebook, YouTube. Later we'll do understand like how we do control the traffic, which is like how we do block or allow traffic for particular website. That's different concern. But as of now, we'll have to understand the netting portion. So whatever the website or whatever the application you do use, that you can check. See guys, everything working fine. So that's called your source NAT or source portion translation. In order to again verify it, what we can do, we can check the latest log. It should identify the applications also. So see, whatever the traffic which is going from LAN to WAN, which rule basically allowed the traffic? Allow internet LAN. Google based DNS, whatever the traffic you are trying to use, every traffic will get allowed. If you do check other traffic, so you can do filter it. So see, if I want to filter Facebook, I want to check Facebook traffic. So I can do use filter equal to Facebook base. So whatever the traffic which is going for Facebook, you can check here. See, 10.3.3.3 when trying to go on destination here. So Facebook is basically a secure site, so it's showing 443. So everything looks good now. So again, see, the port number got changed, and which port number now firewall will using a port number which is 11,620 in source, and IP address also get translated from 10.3.3 to 192.168.101.254. Destination portion remains same, and because my firewall is having a GeoBlade feature, so it also showing me this country code, which is United States, as well it's showing the port number also. It is clear to everyone?
Sir, this 192.168.101.254 is your WAN router interface IP?
It is actually Palo Alto WAN IP.
Palo Alto WAN IP.
See,
Okay.
I am doing translation which is based on
Correct. Okay.
port. So when anyone comes from my LAN, so it get translated into this 254. I've already told you this topology which we are using, that's very similar. We are trying to perform translation on WAN interface. Aviral, do you have any concern? Any doubt?
No, not for now.
Sir, what is it like configuration of your internet router? It is netting for this subnet to public
Yes.
IP, correct?
The whole IP subnet of 192.168.101.251.101.0/24 get translated into the public.
Okay. At your
Yes. So for this LAN setup, for this lab setup, my physical firewall is also behind my router. So that's why I'm using this public range as a WAN.
okay, sir.
I don't want to make any difference like when you guys do perform. That's why I'm using the same kind of configuration even at my physical firewall. Understand why I'm doing all this thing? The very similar kind of setup I'm using here also in order to perform natting and everything. So it looks very similar when you do perform. Otherwise, I can use one WAN IP also, which is actual WAN. But I do want to show that it doesn't matter which IP you are trying to use. It is just for your understanding, it is public private. But device will do perform whatever you say. All right.
Okay.
Do you have any concern, any doubt regarding this netting? Aviral
No.
is speaking something. All right, guys. So we'll do perform. We actually done first translation, first type of translation. So as I told you, first we'll have to perform the source NAT. So in source NAT, we done first type of translation, which is called PAT on interface IP. Interface IP. PAT on interface IP, which is configured on my firewall. Let's talk about other cases. Let's say if you have WAN pool, generally when you do work in organization, so ISP will do provide IP range, which is /28, /29, /30 accordingly. All right. So if I ask number of valid IPs in /29, so can anyone tell me how many number of valid IPs we get when we do calculate it, and how many IPs we get in /28, and how many valid IPs we get in /30?
For 30, we got 2.
Yes, for 29,
For 29,
6.
6,
6. Yeah, right.
and for 28,
12. 14.
yes, 14. So guys, how many bits? How many, if I do ask total number of bits and IP version 4, so it's 32. But here we have network bits, which is 28. So how many bits we are using as off bits or host bit? 4. So 2 to the power 4 minus 2, which is 14. In this case, we have 3 bits, which is off. So 2 is power 3 minus 2, which is 6. 2 is power 2 minus 2, which is 2. So see, if you do use this pool, this kind of pool, public IP pool, you got /28. So you have lots of IPs, means you have 14 WAN IPs. So generally you, if let's say this is your ISP and this is your router or firewall, so only 2 IPs you do use. Let's see, X is IP which you configured on next hop of ISP, and Y is the IP which you configured on interface. So how many IPs are remaining in this case? 12 IPs are remaining. So guys, how I can do use these 12 IPs if I do perform the translation on interface only? So there might be a possibility in organization we can do perform translation on pool IPs, which is free. All right, which is not configured on my interface. So next case we'll have to check pool IP translation. Which is not configured on interface. All right. So just come at our scenario and we'll have to check which IP address. So my pool is /24. So how many valid IPs we have? Come on, tell me.
What is /24?
Yes, 254. Which
Yeah.
subnet I'm using /24. So in my case, we have valid IPs, which is 2 raised to the power 8 minus 2, which is 256 minus 2, which is 254. So we have valid IP, which is 254. All right. So that means we can use IPs up to 254. So we have lots of IPs, but I have allotted to you guys also. So let's say in my case, I have a one free pool IP, which is 192.168.101.251. I want to use this for NAT translation. So what all the things we have to do for that, how we can make it done, that we have to understand. So in order to perform this pool IP translation, we'll have to come here on under policies on firewall, we'll have to select the NAT. What next we have to select? The same rule I'm going to use, but I'm just saying this time you don't have to translate on interface. Instead of interface, you have to perform translated address. No, you're not audible at all. That's why I've asked, I think 2 or 3 times, but I didn't get any response from your side. Check your mic. So dynamic IP input address type, which is translated address, and in translated address, I'm going to put my free IP, which is 101.251. So whenever any traffic goes from my LAN, it just gets translated into 251, which is actually not configured on my interface, but it is part of my pool. So people will get translated into this, and people can access internet. Is it clear to everyone? The next case which I'm showing you, see, the interface IP is 254, but the translation IP which I'm trying to use, that just got changed, and now it's showing 101.251. And see the policy. Does it require to change or any change in policy? No, we do not require. So we just have to say LAN trust, WAN untrust, application, and everything remains same. So you just have to say committed. Once you do committed, so it just get applied, and those who want to access internet, who do try to internet access, they always get translated into 251 instead of 254, because now my translation IP get changed from 254 to 251.
So we can add more IPs if we have more.
Yes, you can ask. Oh, yeah, but what about other guys? Can you hear Aviral?
No, no, no.
No. No one hearing your voice. So there might be some issue with your mic. I think you should use your headphone. Normal headphone can also work. See guys, so once your policy just get committed, we can check the result. So for organization perspective, whenever anyone asks, whenever you do perform netting, so you have to be very clear that you can do perform netting, which is on WAN IP, as well you can also do perform netting on pool IP, which is not configured on my WAN interface. But there is few tricks, there's few things which we also have to understand once we do complete this. So in order to check what's going on, we just have to wait for commit. Once it get committed, we can do perform other tasks. So just come on here on Windows 3, it's look good, is I think already running here, and Windows 2. So this is also part of my LAN. So I can do initiate traffic from 2 and 3 in order to test it. See, window 2 is also here.
And there is a kind of load balancing between the IPs in the that we configure in the pool.
In case of dynamic NAT. But for source NAT, there is no load balancing. As such, there is no advantage of load balancing. When we do perform destination NAT, then I'll do show you load balancing portion also in this. In source NAT, there cannot be load balancing, but it can be like we can do use multiple IPs. One IP we can do use with one LAN user, another IP which is available in my LAN pool, that I can do use with any other user. In this way, we can do use.
So in that NAT, we can use any IP that is in that pool, right?
Yes.
Okay. So
So see, this is my PCB. So what IP address I'm using? (33) subnet mask is this, gateway is this, DNS is also correct. So we'll have to verify interface connectivity. Does this machine is able to ping with the gateway or not? So see, gateway is pingable. So it means we can do start, we can do check the NAT portion also. So in order to check NAT portion, we'll have to come here on firewall, we'll have to check it, whether the policy get applied or not. So see, policy get applied and it's look good. Now we'll check the connection from Windows 2 itself. So in order to start a communication, we can use any browser in order to test it. So let's say again, I'm going to do try Facebook. So see guys, it is still working, but this time we just change IP address from 254 to 251. If I do try to access google.com, so it is also working. If I do try to use cisco.com, so it is also working. So it means we are fully internet access. We have full internet access, but this time we are not translating on interface IP, which is configured on WAN. This time we are trying to translate on IP, which is basically my pool IP. So we change IP address from 254 to 251. So in order to cross verify, we'll have to go on firewall and we can verify the log. So again, you have to come on Palo Alto and in this address bar, you can do filter this. See, there's already a log which is showing for Facebook and all. So you can do use anything. Let's say I'm again going to do verify Facebook. So you should call two conditions here at log, and you can do change application. See, I have just filtered source IP. Along with source IP, I have filtered application also. In order to cross check, we'll have to open the log and we'll have to verify the translation IP. So see guys, in this case, we also translating the source port, but this time source IP of LAN get translated into pool IP, which is not configured on my interface of firewall. And the destination address is showing here for Ireland, and the destination portion remains same. Now guys, there is one question which I'm going to do ask. This is very important to understand. Further, you can do again cross check interface IP which is configured. 254, but we are translating into 251. So that's why I'm saying it is my pool IP. Let's try to come on firewall on the diagram or the topology. So this is my topology which I'm using, physical topology. So see, my scenario is like this. This is my router, which is acting as a ISP. What IP address I have configured on interface of router? So IP address on interface which I have configured is 192.168.101.1. Is it clear to everyone? And the IP which I have configured on interface. So guys, whenever this ISP trying to send a traffic on 101.250.1, so let me just change IP address which is configured on interface. So which IP address we configured on interface? 192.168.101.254. But pool IP I have tried. So which pool IP I have tried for translation? 192.168.101.251. All right. So guys, when anyone trying to ask for this particular IP, which is actually not configured on my interface. So when this machine trying to send ARP request on my IP, which is actually pool IP, so can the firewall reply for this ARP? No, because it is not configured on any physical interface. So in order to make it connect, in order to make it communicate, your firewall will do perform what? Proxy ARP. Instead of denying traffic, instead of denying for MAC address, it will do provide the MAC address of interface, which is basically configured with original IP. So what original IP we are running here? 254. So it is configured on WAN interface. So there must be some MAC address. So AB, let's say my MAC address. So when anyone asks for this 251, the same MAC address it will provide for 251 also. Okay, for two different IPs, now ISP is learning same MAC address. So that's why we called it proxy ARP, and it is automatically done by your Palo Alto for pool IPs. But in case of checkpoint, you have to know how we do manually add this proxy ARP entries in order to make internet connectivity, or in order to perform a proper NAT configuration in checkpoint. You have to perform entry for proxy MAC. But in case of Palo Alto, it just get automatically done. So your next hop device will get the same MAC address which is configured on your interface. For pool IPs, it always do reply with the same MAC address. So that's we call proxy ARP. So if someone asks about proxy ARP, so you do have to remember this scenario and you have to tell the answer. Proxy ARP, when we do perform a pool NAT, or when we do provide the same MAC address for two different or multiple IPs, so that is the case of proxy. All right, guys. Anyone have any concern? Especially when someone do ask about netting, so people can do ask about this proxy ARP also. So proxy ARP is nothing. It's just a way to provide the MAC address if IP is not configured on interface. So I'm going to write one line here. Proxy ARP will help out if IP address is not configured on interface, on interface. Proxy ARP will help out if IP address is not configured on interface. So it do reply for ARP with configured interface. I can do cross verify you. So I'm just going to show you the next hop. So this is my next hop device where I have configured actually. So if I do show you the IP, see the next hop IP which we do ping. Sorry, if config. See, this is the IP address which we do use for WAN connectivity, which is the ISP IP we called it. So if we do check the ARP table of this device, so again check the same MAC address will reply by my device for both IPs. Let me just enlarge this. See now. Okay, guys. So can you please tell me which IP address we configured on firewall? See, if you want to learn properly, so you have to remember the scenario. You have to remember the exact scenario which we are talking about. So every time when I do ask, so at least try to respond. So I can do understand you are in picture, you have good understanding, you are learning. Otherwise, how I can do understand you are learning the exactly which I am telling. So come on, guys, which IP
Sir,
address I have
in
configured on interface?
254.
254.
254.
Yes, good. So which MAC address I'm doing or learning on 54 on the behalf of 54? 7010. So we'll have to verify, cross verify. Where we can do cross verify, we'll have to come here on network interface. See what MAC address next hop device is learning 7010, which is very correct. 6E7010. See here 7010, 6E7010. And once I do perform NAT on pool IP is this 251. Am I correct?
Yes.
Exact IP, yes. See, the next hop will learn the same MAC address.
Yeah.
T49, 3B6, there is no change. So that's we called proxy ARP. Who is performing this proxy ARP? Your router, sorry, your firewall, your Palo Alto. In Palo Alto, proxy ARP, when we do perform for pool IP netting, it always do perform automatically. Still, if you have any concern, any doubt, you can ask me, because these things always do asked by interviewer. You should have to be very clear if you are writing that you have understanding about NAT. So you have to be very clear each and every step, and you have to be good in terms of theory also. Anyone have any concern? You can ask me. Come on.
Okay, sir. Where in what scenario we need to require such configuration, wherein we can just configure the IP from the pool?
So if we have multiple IPs, if we have
Yeah.
a large pool of IP addresses, 28. So some people say, okay, don't use this interface IP, do pool IP for translation. it is design perspective. We have multiple IP addresses. So instead of using this WAN IP address, which is configured or interface, we can do use pool IP address. And other REST IPs we can do use for static mapping also for destination NAT. Later I will show you how we can do perform destination NAT. So if we have multiple IP addresses, so for some design perspective, people do say you should have to perform NATing for this particular subnet on pool IP instead of interface. So it's all about design perspective. It's all about your scenario. So normally, if you have multiple IP addresses, so people do divide IPs. For some IPs they use for translation. For some static IP addresses, they do use for web servers to live web server. So people can do access web servers from DMZ. So it's all about design perspective, but you have to be very clear. All right.
Okay, okay.
Okay.
So see guys, the next thing which I'm going to show you, a bit complex, but it is very good in terms of understanding. See, I'm using physical firewall, but still I'm going to do some change here in to make this ease for understanding. The Palo Alto, I'm using your laptop. Now the scenario will bit clear. Instead of this, I'm using physical firewall, nothing else. Am I correct?
Yeah.
And it is connected with internet. So when you guys do perform practical, you have to be only use like this. So see, guys, let's say now I'm going to do some change. This is my LAN IP, and I'm going to show you the server IP. Okay, there is some duplicate IP. Here I'm going to do configure IP address, let's say, which is 48. See guys, I can do ping my next hop as well, because I have performed translation for the whole range, so I can do access internet. All right, but just suppose we have another subnet below this router, like this. We have another LAN range from this router in my LAN segment of organization. Okay, instead of this router, I have to use switch. So behind this router, we have some users. They also require internet, let's say. But there's a few change in configuration. They are using different LAN segment. They are using some different IP address. Like, let's say they are using IP subnet, which is 10.99.99.0/24. This is the IP subnet. And someone says you have to perform NATing for this IP subnet. So how you can do perform NATing? So guys, there is nothing much change. First, we'll have to configure. There must be IP address which is configured on interface. So on which interface IP will configure 0 by 1. So interface 0 by 1 will configure with this 10.99.99.1.255.255.255.0 and then no shit, exit, exit, and write. And here also we'll have to configure IPs accordingly. See guys, in LAN segment, we already performed the netting. We already performed the netting and we have allow rule. So if any traffic come from 10.99, so it comes here at router, router will send to switch, switch will send to Palo Alto, and Palo Alto will receive at which interface? At LAN interface, which is part of trust. So traffic will allowed because I've already told to firewall that when traffic come for trust, it should get allowed. See the rule. When traffic come from LAN trust and trying to go to WAN on trust, so it should allow. And netting is also there. Anyone who's trying to come to access or who's trying to go to outside will get translated into this NAT rule, which says LAN trust trying to go to WAN and trust get translated into 251. So the same we are trying to perform for this subnet. See, if I do try to send traffic, wait कर लो भी बाहर थोड़ी देर, बैठ जाओ सोफे पे. So host name, a router, or we can say user 1. I have given this next hop also. Now see, with ping.4.2.2.2, we have still allow role, we have everything, but we are not getting internet. Can anyone tell me why? Why this subnet cannot do access internet if we have everything? But if we do check the internet connectivity with this range 10.3.3.3, so it do work. See,
Sir, we need to check routing table
where we need to check routing table.
for this subnet, like if any written route is allowed for this or not.
Yes, we'll have to check the return route. And what else we have to check? See, if I do ping with this, so it is working fine from 10.3.3.3 range. So guys, at firewall, you have to mention one return route. So in organization, there can be only two cases for source NAT. First is you can do perform netting for directly connected interface. As well a subnet which is not directly connected. So see, I've just pointed one default route from this router, and what actually I pointed 0.0.0.0.0.0 and 10.3.3.3.1, and here also I'm using the default route pointing to this interface at this router. So when traffic comes here, so it goes to router will send further to firewall. But when reply traffic comes, so firewall doesn't know about 10.99.99.0 subnet. So in order to allow return traffic, we'll have to give one static route on firewall pointing to this interface. So when subnet is not directly connected, so you always have to remember you always have to take care about the routing part. Once you do clear this routing part, it will do work. See what I'm trying to say? So only three things you always have to check. First is you have to be very sure about your policy, NAT rule, and after then you have to think about this routing portion. So in order to allow return route, we can do create one return static route for which subnet. So see 10.99.99.0/24 is the subnet, and from which interface it should point it LAN interface, which is 1/2, and the next hop IP. Come on guys, tell me next hop IP 10.3.3. So this is next hop IP 0/0. So what IP we configure? So IP interface brief. So 48. Once you do configure this, you just have to say okay. Now close this and commit it. Once you do commit it, so you have returned out also. And once you have returned out, so you must get internet access on the router, which is not on the subnet, which is not directly connected with firewall. So guys, in organization, anywhere where you do work, there can be only two possibilities. If you do perform NATing for connected subnet, so you don't have to much worry about routing part. But if you try to perform a NATing for subnet which is not directly connected with firewall, so you always have to rethink about routing. You have to check your routing portion. You have to think about routing, whether the return route is there or not, whether the routing is okay or not. So once you do check these three things, your route, your netting part never get failed.
Sir, if there are multiple subnets, so we
So
may
for each
use like
subnet,
dynamic routing.
it depends on design, but we can normally we do use firewall. We do use static routes and default routes, because for routing concern we do use other devices routing. But Palo Alto do support OSPF, BGP, these RIP. So I'll do show you how we can do configure it.
Okay.
See, it's not committed yet. So we just covered half part of the source net. There's a few more things in source net, which most probably we'll do cover in next session. Till you all have to be perform all these practicals which we done till. So in organization, the major task is based on netting, policy, configuration. So you all have to be understand this. Even in some projects, there is only work of netting and policy, especially in companies like BT, SCL. So the whole task is only for netting and policy. People do work only on netting and policy. So if you are good in netting and policy, so you can easily do clear the interview on the basis of this netting and policy. You say, in my last organization, I was doing some netting and policy work. Along with this, I was doing some monitoring and some switching work. So people do consider, oh, the person has good understanding about netting, so they just do hire you. You cannot be very good in everything at initial, but you can be show at yourself up to mark in particular one or two things. Means you can show you are expert. So see, you have to come here on router, now try to send traffic. So it must be pingable, it must be reachable. See, you got the internet access on this router also. I can do show you the log also. So in order to check log, you have to come on here at monitor portion. Which IP address will have to filter? We'll have to filter 10.99. 10.c, there is lots of log for 10.99.10. So in order to check it, you just have to click on here on log portion and you see ICMP traffic, and it just get allowed by allow internet policy, and you got the access. This is an Australian IP which you are trying to ping it. So it's all good, guys. We'll meet on next session. We'll do further continue till you have to practice each and everything, and you have to read it properly. Source net, destination net. I'll do share some documents of netting also. Anyone have any doubt, any question, you can ask me.
Sir, one more thing. You are starting some ASA batch today evening.
No, I don't know about new batch, but it started, so you must get information.
Okay.
All right, guys. Anyone have any concern?
Not yet. Once we done the practical part,
Okay, all
if
right.
we have, we will.
So we've done lots of things still. You have to just correlate each and everything, and you have to go through with theoretical documents as well. You have to be good in practical also, because there is lots of tasks which is only based on practical, and for practical purpose, you have to be good in theory. Okay, guys, bye. We'll meet on next session and we'll do start further task.
Okay,
All
thank you.
right. Okay, welcome. Okay, not an issue.